Hello, this is the TrebleSynth modular synthesizer on a chip. The chip is a Raspberry Pi Pico RP2040. This is like a Raspberry Pi Pico board, but I designed it myself, but a regular Raspberry Pi Pico board can be used. The way it works is on the chip, the effects are implemented digitally. You define the modules you want, and then you define how they're connected together, and then you can assign the various controls of these modules to these knobs. So let's go through the features of this. So there are 25 knobs. Sorry, there's 25 buttons, and then there's 21 of these knobs, and this acts as a MIDI keyboard. These knobs you actually assign to the various controls of your modules to adjust them. There's an audio input, an audio output, a power barrel jack input, a MIDI input, which I have a keyboard connected to. And you can actually do quiet. It'll do quiet and loud effects, the velocity effects. There's a MIDI output. There's a OLE display. There's a USB, and the USB implements, you can do power through it, and it also acts as a USB MIDI device where you can play the synthesizer, say, from a computer, or you can send the MIDI events from these keyboard buttons to the computer. There's also two jacks here for expression pedals, and there's this keypad here which you use to enter the commands into it. So those are the basic features of this, and I will now show you how the module structure of this modular synthesizer on a chip works. Okay, now we're going to examine the simple synthesizer arrangement with 3 modules. And so to do that, I'm going to go into the synthesizer adjust menu. So we'll see unit 1 is a VCO or voltage controlled oscillator. Unit 2 is a low pass filter. And unit 3 is a envelope attack decay sustain release. And it adds an envelope to the signal. So let's go to VCO first. Now what you can do is when you get onto a unit, you can select the type, so VCO, ADSR, low pass filter, low frequency oscillator, voltage controlled amplifier, mixer, ring modulator, and noise source. So we're going to leave that a voltage controlled oscillator. Then what we can do is each module has a source unit, and it says where it gets its audio from that it processes. So a unit number of 1 means that it gets the audio from the previous unit. So source unit of 1 means it gets it from unit 0, which doesn't exist. So that corresponds to a unit with a input with no signal. But for example, if you set source unit to 2, it would get the input from its unit 1. So each unit also has a control unit, and so for example, that's where it gets its control signal from. Now for example, the control signal for a VCO modulates its pitch, and so if you're doing FM synthesis, you would use this so that you could get one VCO to modulate the pitch of another VCO. The oscillator type, so this is oscillator type number 6, which corresponds to a square wave. So for example, okay, now for example, if I change that to 5, that's a sawtooth wave. But I'll change it back to a square wave right now. Okay. Amplitude tells you the amplitude of the signal. So you can change that, and you can set that with a knob. The harmonic, you can set the harmonic number. Now this is especially important, for example, for FM, so you can set a VCO to the harmonic of the signal note being pressed. So for example, if I set harmonic to 2, harmonic to 3, etc. Okay. So then you can also set the control gain. This is how much it changes in response to the control. Of course, this doesn't have a control connected, so this is not going to do anything. The bend gain, for example, we can set the bend gain at 1. And so, for example, I have a MIDI keyboard hooked up to this. So if I press this, for example, that makes a note. It'll bend the note. And then I can set the amplitude and gain control. So that will, now those are presently 0, so that means they're not connected to any potentiometer, but I could do that if I wanted to. So that's the controls for the VCO. Now I'll go to the low pass filter. This is a source unit of 2, which means it gets its input from unit 1. Has a control unit of 1, which means it doesn't have, it's getting no signal for that. The low pass frequency is certainly set to 242. There are 4 stages of low pass filter, and I have the low pass frequency set to 1. So for example, if I turn 1, you'll see at the bottom of the display it says LP frequency, and you can see this bar goes up and down as I turn the knob. You can also see the number 02 indicating the module number that I'm adjusting it for, the unit number. So for example, you'll see as I turn this all the way up, but as I turn it down, it both gets quieter, and the timbre changes because of the low pass filter. So now there's also the envelope. I'll go into the parameters for that. So it has a source unit 3, which means it gets it from the unit before, which is the low pass filter. A control unit of 1, which means it doesn't have the control. Attack, decay, sustain, and release levels. And then finally, I'll get into the output type later, but we have attack control set to 2, decay control set to 3, so that's knob 2 and 3, sustain control set to knob 4, and release control set to knob 5. So what I can do is, those 4 knobs control the envelope. So for example, you can see now attack, as I turn the attack, that knob goes at the bottom. So as I turn the attack control up, it takes longer to attack if I turn it down. Similarly, if I have decay up, decay takes slower. Okay. If I set the sustain, sustains at a higher level. If I set sustain off, it basically goes off. And then if I set release, if I set release down to minimum, it goes off right away when I release the button. If I turn this up, it rings a while after I release the button. So that shows you what the controls do. So this is a basic control scheme for 3 modules that I set up. So now I can use these knobs to modify the sound. Now I'm going to show some other examples that I have saved on here. So what I'll do is I'll go back to the main menu, and I'll go to load, and what I'll do is I'm going to choose here FM as an example. Now if I play some notes, you can hear that there's a FM like tone coming here. Now I'll show you the units that were done to do that. So I'll go back to synth adjust. So VCO, there's a VCO and a second VCO and an ADSR and that's it. So let's look at the first VCO. So what I'm going to do here is the source unit's 1 because it's not getting its input from anywhere. Control unit's 1 because it's not getting a control input. The oscillator type is 1, which is a sine wave. Amplitude is 255. The harmonic number is 1. Now we can change that if we want to change the timbre of the FM signal. The control gain is 1. The bend gain is 1. And so what we've done is we set the amplitude control to knob 6. So if you notice, if I turn knob 6, it says VCO amplitude. So you notice that, for example, it says 01 for the module number, VCO amplitude, and then it has a less than symbol at the left-hand corner of the screen. That's because when you reload a module, the knob position is not necessarily where it was before. And to be able to adjust the control again, you have to turn the knob back to the original position it was when it was saved. So to do this, the less than symbol means it's smaller than it needs to be, so I'm going to turn it up. And once I get to the right position, you can see it turn to a star. The star means that it's now adjusting. So for example, if I do this now, that knob is now adjusting the timbre of the note. So, well, okay, and there's no gain control on this one. Now what I'm going to do is I'm going to go to VCO number 2 and show how this works. So, unlike before, if this was getting its audio from the previous unit, this VCO in unit 2 would have a source unit set to 2, but instead it has a source unit set to 1. This means that it's not going to take its audio input from the previous VCO, it's going to take it from the no signal source. So you just set the source unit to 1. Now, unlike in this case, we have the control unit set to 2, which means we are going to get the control from the VCO in unit 1. What this will do is it will allow the VCO of unit 1 to modulate the pitch of unit 2. That will that'll cause frequency modulation. And that's how we accomplish that. Oscillator type for this one again is 1, which is a sine wave. Amplitude is 256. Harmonic is 1. Control gain is 52. The bend gain is 1. Now, in this case, we don't have the amplitude control, but we do have the gain control set to 7. So you can see here that now when I turn the knob, it says VCO gain for the gain control, and O2 is there. So for example, okay, this is showing you again how you can change the timbre with these two controls. Now the third one has the ADSR set up as before, with the 4 knobs controlling that, 2, 3, 4, and 5. So again, you can still use these 4 knobs to control the envelope. So there is a simple example of frequency modulation using 3 units. I will now show a more complicated example of frequency modulation, actually using 2 chains of frequency modulation that are combined together. How do I do this? So I have this already saved, so I'll go to Load, and I'll choose FM2 Bank 4, and I'll play it for you a second here. And so what there actually are here is there's actually 2 separate chains of FM, each of which has 3 VCOs in it, so there's 6 total VCOs. There's 2 ADSRs and a mixer to combine the output of both chains together. And I will now show you I won't show you all the parameters because that would take a long time, but I'll just show you how these are arranged in memory. So if I go to synthesizer, unit 1 Unit 2 and Unit 3 are all VCOs. Unit 4 is an ADSR, and it's set to basically just produce a brief tone, that bong you hear at the beginning of it. And then there's a 5, 6, and 7 are also VCOs, and the ADSR unit of this produces the long tone. And then finally the mixer is combines those two together. So that is an example of that. Now, for example, there's about, I think, 18 or 19 of these controls set up. So for example, I can adjust some of these. So you can hear that if I change the attack on the first one, you can hear that the beginning bong get a little bit longer. So that's an example of how you can assign a lot of these controls to different modules, and it shows you when you turn the knob which module corresponds to which knob corresponds to which module and control. For the last example, I'm going to show something simple, which is just a simple example of vibrato. Alright, so that's how does that work? So it's simple. We have a low frequency oscillator, and that controls the VCO, that controls the low pass filter, that controls an ADSR. So the low frequency oscillator generates a signal of 6 hertz. So for example, I could set it to 16 hertz, and it goes much faster. And I don't have a frequency control on this, but yeah, so but anyways, you can see how now the second VCO here has a control unit set to 2, which means for the previous one, and the control, like I said, it has the vibrato. It has a control gain set to 1, which sets the amount of change in the pitch based on the low frequency oscillator. So for example, I set this to 3. That would increase the amount of vibrato. So to give you an idea of what that is. So that's how so the LFO modulates the VCO, and then there's a low pass filter and an ADSR. So other things I'd like to mention about this is that you can plug it into a computer, and it enumerates as a MIDI device and a COM port, or a virtual serial device. The MIDI device allows it to, you can play through this, you can play notes from the computer through the synthesizer, or alternatively, you can send events from the little keyboard here to the computer. The COM port allows you to issue commands to it, and you can read the configuration out of the device using commands. So you can inspect it, the configuration, and save it by just saving the contents of the terminal. And you can basically re-enter the commands that it sends you into the terminal to recreate the parameters to be able to reprogram your synthesizer. Another aspect of this too that you should not forget is that this also has effects as well. So if we go to filter adjust, right now we have a compressor on there. What the compressor does is it basically, for example, it will make quiet sounds louder and even out the volume, so make it a lot easier to hear. You know, if you have a wide dynamic range, it'll compress it. You know, there's other effects in here too. So for example, there's a delay effect. So that's what's producing that effect. So without the effect, you can hear. Now if I add the delay back, and so there are other effects here too, like all these effects are taken from the guitar pedal I made. So for example, there's a flanger. So you can get all kinds of weird effects that way too. So, like I said, you can also cascade these effects as well. So, for example, I can have the compressor before the flanger. Well, actually, for example. So, there's a lot of options here if you want to be able to process your audio, and they all occur on the chip. So anyways, this is all open source hardware and software. Look below for the link to the GitHub project. As you can see, all the parts are very simple parts. These are all readily available. LM358, 4051, etc. A common OLED display, and of course the Pico, Raspberry Pi Pico is a very common board, so you can easily build this yourself. Anyways, thanks for watching, and I hope you are interested in this, and maybe you'll try to build one. Thank you.